Good morning, my fellow students. And today I have had a chance of getting a question here that demands that we get a particular temperature when other conditions in the environment relating to certain chemical compounds are changed. And this is gas laws, and this is again your online tutor, Mr. Ngata. So I'm going to read the question pertaining to what I've actually said. Then we shall be able to proceed and get the answer to the question as per the examiner's expectation. So the volume of a sample of nitrogen gas at a temperature of 291 Kelvin and 1.0 times 10 raised to 5 pascals was 3.5 times 10 raised to negative 2 meter cubic. So the question says, calculate the temperature at which the volume of the gas would be 2.8 times 10 raised to negative 2 meter cubic at 1.0 times 10 raised to 5 pascals. So I would first be able to tell you that this must be able to apply the concept of a law called Charles' law. Charles' law states that when a particular condition like pressure is constant, then the volume of a given mass of a gas is directly proportional to its absolute temperature. I repeat, the volume of a given mass of a gas is directly proportional to its absolute temperature provided pressure is kept constant. That is what Charles told us in relation to how temperature, which is absolute, and volume of a gas would relate when pressure is kept constant. And he says these two variables are directly proportional to each other. And then, how then do we end up getting the answer to this question? So I'm going to say, for example, volume 1 given in the question is 3.5 times 10 raised to negative 2 meter cubic, which is the same as 0.035. And we are told again that the volume of this gas changes, and of course the gas is nitrogen gas, which forms 78% by composition of what we have in the air. And this gas forms the inactive part of air that slows down the rate of combustion, just in case a particular thing in the environment catches fire or undergoes combustion. So, and the question tells us the volume changes to this. And another condition to capture in this question, as per what you have been given, is temperature. So you have temperature 1, which is 291 Kelvin. You see, Charles maximized his experiments on using temperature in Kelvin. And he says that an absolute temperature is a temperature where the volume of a gas is thought or theoretically zero. The temperature at which the volume of a particular gas is thought to be zero. So that means if that temperature has to get captured here, we are trying to imagine if that temperature we are talking about as absolute temperature. Let me just give an example. Is given as 0 degrees Celsius or negative 273 Kelvin, then that means that must be a very good example of an absolute temperature, where at 0 degrees Celsius, then that temperature must be able to have a particular effect on the resultant availability or absence of a particular gas. So I'm trying to imagine if I'm given a condition like this, where temperature has to change from 291 Kelvin to a particular temperature which is not known to us, and we are again told that there is a change in pressure, and this pressure is actually able to end up remaining the same. So I have pressure 1, which is 1.0 times 10 raised to 5 pascals, and of course we are told that pressure in this topic can get measured in pascals, in millimeters of mercury, in centimeters of mercury, in newtons per meter squared. And he said 1 atmosphere, for example, is equivalent to 760 millimeters of mercury, or 76 centimeters of mercury, or equivalent to 1.01325 times 10 raised to 5 pascals. So then I have to capture the other pressure, which remains constant, 1.0 times 10 raised to 5 pascals. Now, why did I say that this question demands the use of what we call Charles' law? Because pressure remains constant if there's a change in either temperature or volume, depending on which first variable undergoes a change. So as long as pressure is constant, then that means that is Charles' law. To mean volume and temperature are going to be directly proportional. When volume increases, that means temperature must also increase. Or when temperature increases, the volume must also increase. So as we proceed forward, you're going to say now, volume 1 over temperature 1 should be equal to volume 2 over temperature 2. So I don't want to get so much bothered about the pressure because the pressure remains constant. So what is our volume 1? So I shall be able to have 0.035. 3.5 times 10 raised to negative 2 is the same as 0.035. So divide this by the first temperature, 291 Kelvin. And this must be equal to the volume 2, which is 0.028, equivalent to 2.8 times 10 raised to negative 2. Then divide this by our new temperature, which is unknown to us. So we shall just cross multiply. We shall be able to have 0.035 temperature 2 should be equal to 291 multiplied by 0.028. Okay, we'll proceed from here. Okay, so we are going to have divide by 0.035, divide by 0.035. So my temperature 2, as per the question's demand, is going to be equivalent to, let me just pick my calculator. So I'm going to have 291 multiplied by 0.028, and this answer must be divided by 0.035. So that my answer is going to be 232.8 Kelvin. And because the question was not so specific, we can give our answer in Kelvin, or as well be able to give our answer in degrees Celsius, or temperature 2 can as well be equivalent to. So how do I change from Kelvin to degrees Celsius? I just say minus 273. Correct. So I'm going to have negative 40.2 degrees Celsius. So that becomes our final answer to that question. So we have actually said that at an absolute temperature, we can actually be able to change from degrees Celsius to Kelvin. For example, if someone says 0 degrees Celsius has to get converted to Kelvin, what do? I just say plus 273. And what do I get? I'm going to get 273 Kelvin. I have a temperature like 20 degrees Celsius. I want to change it to Kelvin. I just say plus 273. What do I get? 293 Kelvin. And I may have a temperature like 600 Kelvin. And I want to change this into degrees Celsius. What do I have? I have to actually say minus 273. So that we have 600 less 273. We're going to have 327 degrees Celsius. So 0 degrees Celsius or 273 Kelvin can actually be able to get referred to as our absolute temperature. To mean that you can actually be able to record your temperature on a normal thermometer or an absolute temperature reading scale. So that 0 degrees Celsius on our normal thermometer reading in terms of the temperature scale should be able to record 273 Kelvin on our absolute temperature scale. Thank you so much for your time.